also need to learn about summation notation. This is the capital letter sigma in the Greek alphabet, and in mathematics it always refers to a sum. Now when you are reading this, you have two indices below and above the summation notation. The number on the bottom tells you where to start, and the number on the top tells you where to stop inserting numbers. Now this is usually pronounced as the sum of 2i plus 7 as I goes from 1 to 5. For those of you in computer science, this is like a for next loop. We're going to substitute in 1 first, then 2, then 3, then 4, and stop at 5. And then add, because this is a summation, all of the terms together. So we will have 2 times 1 plus 7 is the first term, and then 2 times 2 plus 7 as the second term, etc., until we get to the fifth term, 2 times 5 plus 7 as the fifth term. The first term is 2 plus 7, that's 9. The term after that will be 4 plus 7, which is 11. We will then have 13 and 15 when 3 and 4 are substituted in, and then finally 17 for that fifth term. Now this is no longer a sequence, this is a series because we have plus signs between the different terms, and this is going to equal 65. Whenever you are dealing with summations, the directions usually say evaluate or find the sum. Okay, let's try this again. For this summation, we're substituting in the values 2, 3, and 4 because the starting index is 2, the next index is 4. So we are going to have 1/3 squared plus 1/3 cubed plus 1/3 to the fourth power. This will equal 1/9 plus 1/27 plus 1/81. These can be all put over a common denominator of 81. Since 9 goes into 81 9 times, 9 over 81 is equivalent to 1/9. 27 goes into 81 3 times, so 3/81 is equivalent to 1/27, and we know about the 1 over 81 already. Combining these together, we get 12 plus 1, we get 13 over 81 as the value of that sum. In this next problem, we're asked to find the sum of 4 as I goes from 1 to 50. Basically, what we have here is 4 plus 4 plus 4 plus ... plus 4, and this is going to show up 50 times. So basically, we have 4 times 50, which is equal to 200. Okay, in this next problem, they want us to write this series using summation notation. Now, sometimes this is easy, sometimes it's not. Luckily for us, we have a formula for the nth term. So basically, all we have to do here is say, this is the sum as I goes from 1 to n of this formula n plus 2 over n cubed. Now let's verify that this works. When we substitute in 1, we get 1 plus 2, that's 3 over 1 cubed. 3 over 1 makes the 3. Let's try one more. Let's substitute in n equals 2. 2 plus 2 is 4. 2 cubed is 8. We have 4 over 8, which reduces to 1/2. And yes, this is the proper formula put in summation notation.